first off, we have the different types of main sequence stars. So we have regular stars, which are main sequence like our sun. So these are either orange or yellow or dwarf stars. These are types of stars that basically, they have nice long 10 to 13 billion year lifespans, somewhere around that. For our sun, it's going to be about like 10 billion years. Others, it's going to be a little longer, but depends. Like orange dwarfs, they actually live up to 30, 40, some of them 50 billion years because, you know, they don't even have to work as hard. So orange dwarf stars are actually considered the best types of stars for life, right? So
Can I stop you for one question
sure.
though?
What's the question?
You said about the different colors of the stars.
Yes.
And I've been hearing people saying that our sun is actually not as yellow as it used to be. It's getting more white. Is there have you heard about that?
I've heard a little bit about that. Now here's the thing. The peak of sun, let's get this straight here. The peak of its spectrum is in the yellow range, but it emits a little bit of red, orange, green, blue, and purple light. Yellow is like the color that emits the most of, but it does emit a bit of the other colors too. So I think our atmosphere kind of shows it to be white actually. I'm not sure on that, but what I'll tell you is this. So believe it or not, you think it'd be the other way around. You would probably think red and orange stars are the hot ones, and yellow and blue stars, they're cooler in terms of temperature. Well, it's actually wrong. So get this, red stars and orange stars usually range from about like 4,000 to 7,000 degrees. I think it's Kelvin, I'm not sure, but I do believe it's Kelvin. I mean, that's still very hot, but in terms of stars, that's actually cool. Now we have yellow stars, white stars, they can get anywhere between like 10 to 15 Kelvin. Let me phrase it, 10 to 15,000 Kelvin. That's getting warm, but that's still not extremely hot compared to like blue stars. They are incredibly hot. They can reach temperatures up to 40 or 50,000 Kelvin. So, getting back to what I said earlier, our sun, as I said, is a yellow dwarf. So, the other type of main sequence stars we have are giants. So giants are usually blue stars, believe it or not, and they have to work much harder to sustain themselves. So their average lifespan, some of them, it's only between 50 to 200 million years. Others can live a little bit longer. Like white giants, I think they can make it up to like around 1 billion years at most, but even that's not so much, because you might think, you know, a star living to 400,000 or 500,000, not 500,000, a star living to 400 to 500 million years is a lot, and you know, it might be, but on the scale of a human lifetime, that's like a human dying at 15 or 20, so it's really not that much actually when you think about it. Again, you know, it depends, but yeah, giants, those stars die much quicker. So this is what happens with main sequence stars when they're becoming in the process of dying. So our sun is about 4.7 billion years old right now, so it's like just under halfway. It's around 10 million year lifespan, right?
Are you saying it's older than the Earth?
Yes, the sun is older than the Earth. The sun is what basically started the formation of the solar system. So here's what the sun, when in about 1 billion years from now, between 500 million to 1 billion years from now, its luminosity will increase around 10%. It might not sound like much, but it is. Temperatures on the inner planets, especially Mercury, Venus, and Earth, will swell. On Earth in particular, could come anywhere between 50 to 100 degrees hotter than what it is now. Of course, maybe, you know, it might be differ a bit between like the poles and the equator region, but still. Basically, here's what's going to happen. The sun, in about 4.5 to 5 billion years from now, will exhaust the fuel in its. Here's what happens actually. 4 hydrogen atoms inside the sun become a helium atom, and that happens very quickly each second. I mean, thousands of hydrogen atoms are merging into helium atoms, right? But here's what's going to happen. Eventually, it's going to run out, correct? So what's going to happen when it runs out? Quite simple. It's going to eventually, the sun is now going to start fighting back, because, you know, the inside's fighting against gravity on the outside, so the outer shells of our sun will expand. So this happens to main sequence stars or average stars when they start to die. Their outer shells expand. And as for our sun, it's expected to expand between 90 to 100 times its current size. So therefore,
it's going to go supernova.
No, don't worry, I'll get to that in just a second. That's not that with our sun, but I'll get to that in just a second. So our sun will basically expand in size. Therefore, it's going to destroy Mercury, Venus, and it will grow to just about as big as Earth's orbit. So our planet might survive, but if it does, it's going to look nothing like how it does now. Not even the most advanced spacesuit could protect us if we tried.
Well,